Welcome back. In the previous video, we learned how halogenation of an unsaturated alkene happens in the presence of a diatomic molecule such as Br2 or Cl2. Okay. In this particular case, we're going to continue our discussion on unsaturated compounds, but this time instead of it reacting with a diatomic molecule such as Br2, we're going to react it with either HBr or HCl. Okay, and we're going to learn it through two different mechanisms. One of them is called Markovnikov's addition. Okay, and the second is anti-Markovnikov's addition. Okay. These are called selective addition, means you can almost be sure on where a particular element when broken off would attach itself to, and that's called selective, you know. So if you're carrying out a Markovnikov addition, you can actually tell the reaction how it will happen. If you're going to carry out an anti-Markovnikov addition, then you can be sure what your product would look like. So it's a selective addition. Okay. And pretty much the knowledge of what you gain will remain the same. So let's just pick an unsymmetrical alkene. Okay, I'm just going to pick this one for now. All right, that is an unsymmetrical alkene. What is an unsymmetrical alkene? If you have groups that look dissimilar on both sides of a double bond, that it is an unsymmetrical alkene, right? Clearly on this side you have two hydrogens, okay, and on this side you have a hydrogen and this remaining group, so it is an unsymmetrical alkene. And to be specific, this is a 1-pentene, right? 1, 2, 3, 4, 5. All right, and if this were to react with HBr, what is our product, right? So this is a Markovnikov's addition, okay? Okay, which means you just have your unsymmetrical alkene and HBr or HCl, okay? That there's no other reactant involved. When it is an anti-Markovnikov's, you will see ether or hydrogen peroxide in the reaction medium, which we will see as we get going. All right, so this is a selective addition, and in a Markovnikov addition, okay, the halogen is added to the side of the double bond with least number of hydrogens. Okay, so based on that statement alone, let's go get our reaction completed. All right, so the Br would get added to the side on either side of the double bond. This side has only one hydrogen, this has two, so the Br would get added here, and let's get another color. The hydrogen would then obviously get added to the side with more hydrogens. You don't have to remember where the hydrogen gets added. You always have to remember the Br, and obviously the vice versa is true, right? So let's look at the actual mechanism for this reactions, which means let's rewrite our reactants. Okay, plus HBr, right? I'm just going to write the HBr as this way. That way it's easy for you to follow. All right, so what's happening? Well, as with the other case, we do know that our hydrogen should attach here, the Br should attach here, right? So the bond is lost to make the bridge, right? And in the process, this bond gets cleaved. And I made that very clear when I first started making this week's video, because you've got to understand where the positive should go and where the negative should go, right? Clearly, that the bond is lost here, right? So the tail, the element that's close to the tail of where it all started gets the positive charge, right? Right? And then obviously, you know, I'm going to write something else here. Leave this in the two hydrogens in blue, and, you know, leave the positive charge actually in pink, and add that extra hydrogen here. And that would, right? The hydrogen gets attached here, right? So that means this would get the positive charge, right? And the Br minus, right? Plus Br minus, right? So the Br minus then attacks here, right? Because positive can only attack a negative charge, right? So that means you will have, let's redraw these two hydrogens in blue, and let's get our pink. This is where our first hydrogen is, and well, no longer the positive charge can no longer exist because the Br comes in with one negative, one positive, one negative cancels out, and that's our Markovnikov's addition. If you see that the Br ended up on the side with least number of hydrogens, and then the hydrogen ended up on the side with more hydrogens, right? Now this is a Markovnikov's addition, and I'll make a separate video for anti-Markovnikov's addition. All right, so stay tuned.